Welcome back, class. Today's video is over congruence transformations. So we're going to go ahead and start with the basic definition of a transformation, and then we're going to talk about the three types. So a transformation is an operation that takes a pre-image and makes a new image out of it. Okay, so the pre-image would be your original shape, and the image would be the new one that's created at the end. A congruence transformation, more specifically, is when the transformation keeps the two figures congruent, so no size or shape changes. And we can also call congruent transformations rigid transformations or isometries. So just so you know that those are two different ways of saying the same thing. There are going to be three transformations that we're going to be referring to. The first one is a translation, then rotation, and then reflection. And these should all seem very familiar to you. We're just going to be talking about them a little bit more in depth. Let's talk about a translation first. So here we have got the definition of a translation. It says it's a slide, that's another way of thinking of it, that moves all of the points of the original figure in the same direction as the new figure. So if you look at the example here, JKL slid into the place where MPQ is. You'll also see sometimes when we're labeling points, instead of giving them all new letters, you might call an original shape ABC, and its image points would be A prime, B prime, and C prime. And that's just another way of labeling it so that we can tell the difference between the shapes. So in this example, it says if the points of the pre-image are 4, 5, 6, -2, and 0, -5, and it's translated left 3 and down 5, what would be the new coordinates? So the key here is we said left 3 and down 5. So the easiest thing to do is to go ahead and think about what happens when we take points and we shift them all to the left 3. Left would be meaning we are changing the x value. So what we're doing is taking every x value and going left 3 or subtracting 3 from it. For the down 5, that means we're going down the y-axis. So we're going to take every y value and go down 5. Okay, so what we're doing is taking every x subtracting 3 and every y subtracting 5. And then we can get our new points. So G prime, if I'm going to write its ordered pair, I would take 3 away from the 4, that would get me 1. Take 5 away from 5, that would get me 0. And that would be my new ordered pair for G. Same thing with H prime. So I'm going to subtract 3 from all my x's because I'm going left 3. That would give me 3. And then go down 5 from -2. That's going to get me to -7. And then same for R prime. Go left from 0. So I'm going to get -3 and go down 5 from -5. That'll get me -10. And of course, you can put all of these on a grid and just count on a grid as well. But it's a lot quicker if you can identify if you're adding or subtracting. So obviously going right 3 would mean you'd add 3 to every x, or going up 5 would mean you'd add 5 to every y. So up and down changes the y's, left and right changes the x's. If you have any questions about that little trick, let me know. But of course, graphing is always a valid way to get those transformations. The next one that we're going to talk about is the reflection. So a reflection you might also have learned as a flip. It's when you take each point of the pre-image and you flip it over what we call the line of reflection and to create the image. So the line of reflection is going to be changing all the time, but the key that you know is that in order to be a reflection, every point has to be the same distance from the line. So in this example here that I've got drawn, C and H would be reflected because they would be the same distance apart from this line. Same with B. It's the same distance apart from the line as G, and then same with A. A is the same distance away from the line as F. So it's a really important thing to be able to count and make sure that you know how far away the line is from each of those points. So in this example here, it says we're going to reflect this shape over the line y equals -1. So my suggestion would be to graph the line first. So y equals -1 is a horizontal line. I'm just going to draw it dotted. And so I want my new shape to be reflected over that line. So that means I'm going to flip every point over. So I have to think about how far away each point is. So point D is 2 away from the green lines because I just counted 1, 2. So that means I'm going to count 2 away going the other direction. So there's D prime. Same thing. Point A is 1, 2, 3, 4, 5, 6 away. So I'm going to count down 6. 1, 2, 3, 4, 5, 6. So there's A prime. And then same thing, B is 6 away, so we'll count down 1, 2, 3, 4, 5, 6. So there's B prime. And then C is also 2 away, so we'll count down 2, 1, 2. And then I could go ahead and connect my 4 points to make my shape. So these are really easy. Anytime you're dealing with horizontal and vertical lines, it's going to be really easy. All you have to do is count. Now the rules are a little bit different when you're reflecting over slanted lines, but that you'll just have to be able to make sure the distances are all the same. And remember, when we talk about distance, we're talking about perpendicular distance. So that would be helpful if you're ever reflecting over a slanted line. And then lastly, rotations, you would also know these as a turn. So this is when you rotate or turn a shape around a fixed point. And that fixed point we call the center of rotation. Most of the time, we're going to be working with the center of rotation that's at the origin. Usually that's a little bit easier, but it doesn't have to be 0, 0. It can be any point on a grid that you rotate around. So there are tons of rules that go with rotations. The easiest thing to know about rotations is that in order to identify the new coordinates, you may have learned back in middle school that the easiest thing to do is turn your paper. Obviously, I'm doing this on my computer, so I just have to rotate the whole grid, but turning your paper will help you identify the new coordinates pretty quickly. The key here is that you know the difference between clockwise and counterclockwise. So if I want to rotate this pre-image, so this triangle, 90 degrees clockwise is going to be going to the right. Then I am going to turn my grid 1/4 turn to the right. Okay, so now when I look at that, my A point, my A prime, is now going to be at the point 1, 0. My B prime point would be at 1, 2. And C prime, when I look at my grid now, will be left 1, up 1, 2, 3. So -1, +3. And once I have those points written, if you want to turn your paper back to where it started, I could try plotting those and see if it looks like it's rotated that 90 degrees. So let's try that here. So I'm going to plot my point 1, 0, 1, 2, and -1, 3. And then I can plot those. So A prime, oops, that's B prime and C prime. If I connect them, it should look like my triangle was rotated 90 degrees around the center, which was the origin. Okay, so if it said rotate it counterclockwise, you'd turn it 1/4 turn to the left. If it ever said to rotate 180 degrees, that would mean you'd turn it twice. So I turn it once, and then I would turn it one more time. That's completely 180 degrees. Okay, and then we could go all the way back. 360 would be one full rotation all the way around. So you have to just pay attention to the direction and the number of degrees. And if you have any questions about the rotations, let me know. But of course, like I said, doing it on paper, that would be the quickest and most effective way, is just turning your paper the direction and the number of turns and identifying your new points.